Okay. Good to go. Okay, I'm going to call to order the 29th Meetup, Hawaii iOS Developer Meetup. Thank you everyone for being here. Appreciate your time. Tonight, the quote of the week, sometimes life hits you in the head with a brick. Don't lose faith, Steve Jobs. We've got some upcoming meetups. Really excited about on July 13th, I'll be doing a talk on bugs. There will be bugs. I really like debugging right now for some reason. I really like the tools in Xcode. So I'll be going over breakpoints and kind of examining code as it goes along. After that, Ryan Hansen, one of the developers of this meetup, is going to be doing a talk on threads in Swift. And then the following week on July 27th, I'll be covering Firebase real-time databases. So that would be publishing and subscribing to the database with Firebase. This week's pro tip, this kind of goes into the debugging aspect, is that I want to showcase how you can pause execution with breakpoints and examine frozen memory with the memory inspector. So I'm just going to start up an app that I'm working on right now and just pause it. Just kind of show how to pause things along the way. Who here has done debugging inside of Xcode? Okay. So this should be pretty straightforward. I'm just going to showcase, I'm just bringing up the console down here. I've got a breakpoint in. I'm going to zoom in a bit so we can see that this is the console output. And the part I really like to stress is this kind of memory inspector. So with the program paused through execution, I can actually dig into actual memory aspects. It's pretty cool. I'll be going over a lot more next time. So back into the agenda. So I just went over the pro tips, shared upcoming meetups. A bit of housekeeping right now. So this is the Hawaii iOS Developer Meetup. Please keep all communications on the Meetup page. We had a lot of good discussion this week. Moving on, we're very lucky to be hosted by HICapacity. If you're interested in becoming a member, you can go to HICapacity.org/membership. And final bit of housekeeping is, if it's your first time here, the bathroom is out this door, all the way out to the grass. Take a right, and then the bathrooms will be on your right. The key right there is hanging on the lanyard. Feel free to just go if you need to. I wanted to share some free tools. I always share these free tools. I really dislike using my mouse as much as when I don't have to. So I really like using spectacleapp.com. It's free and it allows you to use keyboard resizing kind of stuff really fast. The other thing I want to share real quick is screenhero.com. It's a cross-platform screen sharing program where you can share your mouse and keyboard. It's great for pair programming at a distance. If you're interested in getting an invite, just give me your email and I'll send you one tonight. So tonight's agenda, we're going to do introductions, and then we're also going to move into tonight's discussion topic, which is generics. Before we go into the introductions, I want to talk about one thing, and that is the fact that the Hawaii iOS Developer Meetup is going to be moving. We're going to be moving to the iLab, and that's at the University of Hawaii at Manoa. So real quick, I just want to, at the last meetup, I just kind of took a poll of how people felt about the move, and it seemed like pretty much everyone was stoked on the move. So right now I'm just going to bring up, before we go into discussions, just a quick web page of what the iLab looks like. So this is where we're headed. It's a great space. I met with Chad, who's running the iLab, and it's fantastic. These monitors are huge. There's Wi-Fi. It's going to be from 6 to 7. One drawback though is parking is $6 to park on UH campus, but there is parking if you are good at searching for it on the street. So we're going to be moving. The first meetup we're having at the iLab at the University of Hawaii Manoa is going to be on August 3rd. So everything up until that will still be here, but our meetup, when we do the transition, will be August 3rd at the iLab. Does anyone have any questions? Okay, so now I'm going to move on to introductions. So scroll up a bit. Does anyone want to go first? If not, I'll go first. My name is David. I'm from this valley. I'm currently working on a couple of apps. One is a location-based like bar app. I'm also working on a physics-based boxcar, and I'm also working on a quiz app. Currently stuck on not much, and a recent win for me is it's a recent win. I parsed some JSON and finally got a graph working, which I've been working on for a while. Aside from computers, I'm interested in gardening and music. Does anyone else want to go next? Felix?
Hi, I'm Felix. I'm originally from Seattle, but I came here a few years ago. I live in IAF, right across from the Pearl Harbor Memorial. So I'm currently working on learning Swift. I think I just told you that what I'm stuck on is the string class. I understand that they're trying to deal with Unicode, but some of the concepts are new. And I want to learn more about Swift and app development. Part of that is that I want to eventually branch out from my current job and do some freelancing.
Yes.
A recent win for me was actually it's outside of coding. I made a contact and they're interested in hiring me on the side for a freelance job.
Nice.
So not for programming, but something else. So besides programming computers, I'm interested in cooking, music, and thinking.
Cool. Thanks for being here, Felix. Anyone want to go next?
Neil, I think big win for this week. I was able to put it in my app, purchases.
Oh wow, nice.
To set it up, it took me like a week just to like understand and wrap my head around the concepts. Yeah, and
did you end up using Swifty Store? Or?
And then yes, for actual implementation. So I went through how to implement it with just StoreKit.
Okay.
I grasped that concept and then started looking into Swifty StoreKit and then realized it's way better.
Yeah, it's way easier, isn't it?
A lot of the errors that can come up with it and like side cases. So I was able to, it took me like a week, but I was able to add it and working.
Nice.
So and the version 1.3 will coming out like sometime this week.
Right on, congratulations.
Yeah.
That's great.
And of course my first dollar online.
Oh,
yeah,
nice.
yeah.
Oh, man.
I know that's a pretty big deal.
Right.
But with ads,
Nice,
Yeah.
nice.
it's awesome.
Right on.
Wow.
The week.
Cool. Anyway, whoever wants to go next.
Aaron, my name is Aaron. I'm from here, Honolulu. Well, right now I'm working on an Android app, which hopefully somebody can help me with after this. But and then I'm stuck on box.com, downloading a file. I mean, it's getting an exception and I don't understand. And then, yeah, like everybody else, want to learn more in Swift. Then I just got another app released. It's a golfing app.
Yes.
So that's my win. Like, although it's a lot of work, I've just been trying to promote it and but what it does is that if you have a junior golfer, you can watch where they are on the course on your iPhone.
Oh, nice.
So you can track them, so you don't have to worry about where they are.
Nice.
And then, I guess everybody's into music. I'm a musician, and I guess I like golf.
Nice.
Yeah.
Great.
Yeah.
Merritt,
Okay,
you go.
my name is Merritt. I am originally from Texas,
Let's go.
and I'm currently working on an app for my iOS developer class. We're supposed to do an app for the very end of the final project, and it's a chore list. I'm trying to do a chore list, and I'm stuck on getting my data to save right in the chore list, which is annoying. What do you want to learn more about? The more I learn about Swift, the more I realize I don't know anything about Swift. So, like everybody else, I need to learn more about Swift. What's been my recent win for me was getting to the core data part of my course. I hate core data. It is the worst. I hate it so much. And one of my interests in besides programming computers, I am a rock climber. I climb rocks for fun. I play the violin, so music, and I really love the ocean. So there you go.
Cool. Thanks for being here, man. All right, Tyler, Elliot, do you guys want to do an introduction?
Sure. So, I'm Tyler. I'm here. So, I'm not working or anything on Swift right now since I don't have a Mac. I'm going to learn more about Swift. A recent win for me. Nothing really happened to me this week so far, and I don't have any interest besides computers.
Okay. Thanks for being here, Tyler.
I'm Elliot. It's my second time here. I live here, but I'm from all over. I'm from New York. I've been in Taiwan and LA, so I've been many different places. Speak fluent Chinese. I'm working on an app. I started a company designing audio faders for DJs. I'm finding there's a lot of support issues, so I'm trying to do two things. One is I'm trying to write an app that works as a support tool for my customers. The other is I want to do an app to so a DJ can use a cell phone to control the audio fader that is designed, because I'm right now I'm going through a stage of I've done so many complicated things that people, just because I've been trying to support a lot of different customers. I mean, I'm trying to, it's like designing a car stereo. I mean, every car is different, and I'm designing a fader for mixers where like there must be like 20 or so, 30 or so different standards that people use. So, and then the customers get confused. They don't know what connectors to use, how to adjust, because adjustments are different. So I want to try to simplify the process. I think part of that is having an app that's useful. The other is having a Bluetooth connection to the fader that they can adjust right from the phone, and something simple to use. So I'm in that stage. I want to learn more about Bluetooth. As I said before, the recent win is that I actually got pictures on an app, but very simple, very ground level stuff. My interests, I like biking, I like salsa dancing, I like surfing. So I try to keep a lot of different things, and it's like the hardest thing is just focus. And I mean, a business, I run my own business too, so I spent the last 3 weeks trying to respond to the Hawaii government's request for all my sales taxes for the last 3 years, but it turned out to be like $70 because I sell mostly to distributors overseas, but that's part of running your business. So that's where I'm at. Hopefully someday I can find, it's just me running my own business, but I'm trying to hopefully someday have other people involved who can help. So I'm not like, right now I'm a lot of kind of one-man band with only one person helping. So that's where I'm at.
Sounds like you got a lot going on. Thanks for being here, Elliot. Appreciate it.
I just I haven't done any program for 3 weeks. So I'm like, I gotta just come.
This is the place to do it.
Yeah.
Appreciate it.
Get back into it, yeah.
Kyle, you want to introduce yourself?
Sure. My name is Kyle from Kailua. I'm over here. This is my first time coming. Even though I graduated in MIS, I've been out of it for years. So just wanted to come and check you guys out, see what you guys do, and try to see where it goes.
Cool. Thanks for being here, Kyle. Yeah. Okay, so I think that's everyone. Jesse, you want to introduce yourself?
Oh, sure. I'm Jesse. I'm one of the board members of HICapacity. We're going to be moving to iLab pretty soon, along with the iOS Meetup.
Oh, wow.
But we're going to be partnering with them in their space, and then try to bring our mentors over to there. So this will be the last month we're here in MIC. We are taking hopefully our nice lockers with us, but we have a nice streaming setup, and we have monthly memberships, which is going to go pay for cool stuff for us rather than pay for rent. So which is going to be good. So hopefully we'll see some upgrades to some of our streaming infrastructure and things like that over time. But yeah, so we're a hackerspace, and we have monthly memberships. We also have a Slack channel if you're interested in joining that as well. We have about 340 people on it now, so it's a pretty big tech community in Hawaii, one of the bigger ones anyways that I know of. Have fun.
Thanks, Jesse.
Yeah.
Okay, so we just did the introductions, and what do you say we just dive right into it? Okay, so just by a show of hands, who has dealt with generics before? Okay, great. So we'll start straight from the top. So I have a playground ready right now. Bring it up, and We'll make this so we can see it. Command, comma. I'm going for presentation so we can see that. Is that clear enough? You want a bit bigger? Maybe a bit bigger? Presentation large? A little bigger? Okay. Command, comma, presentation large. Let's see what we can do with this. We'll go to the top.
You can see the screen over here.
Oh.
So you want to see what Paul looks like.
That's pretty rough.
Yeah.
That's fine. It'll work.
It's low quality at first, and it's high quality.
Okay. And I see a lag behind it too. Okay. Okay. All right. So let's start from the top. I just want to kind of show that we'll be referencing this website. So this is the Apple documentation, and this is posted in the Meetup page for tonight. What I've done is I've taken all of this code right in here, and I've just pretty much just brought it into a playground. So if you have any questions about what we're covering tonight, you can always refer back to this. Hey, Joanne, how are you? You can always refer right back to this if you have any questions. So we're going from this, we'll go right back into the playground, and we'll start at the top. So I kind of want to start with some discussion before we actually get into generics, so that for the people who have not had any experience with generics, we can actually kind of start with the same understanding and go deeper and deeper and deeper. I've got about 400 lines of code / comments for tonight. I don't think we're even going to get halfway through. But what I'd like to do, I'd like to maybe focus more on why are we doing this? How do you do this? Those kind of aspects. So I guess to start out with, does everyone know what a type is? We're going to start right at a type. So what are types? Does anyone want to just say what a type is, or a sample type in programming? An int would be one, string, double, those kind of things, right? So why would you need to specify a type when you're coding? Like, what's the point of specifying a type?
Grouping.
Sorry?
Grouping, like.
Grouping?
Yeah, like declaring arrays with types.
Right, right. To have an array with all the same like types inside of it, like ints, right? And by leveraging the fact that we have all the same types, we're able to go through the entire array and manipulate it the same way because these are all the same types, right? Okay, so we just, on line 9, we just covered, does everyone know what a type is? What are some examples of types? Ints, strings, doubles, those kind of things. On to line 12, why do we need types? Is Swift strongly typed, weakly typed? Pretty strongly, right?
They tried to make it as strong as
The
possible.
thing that's really complicated is they have the decision between like you're doing CG, computer graphics, as CG float versus float, so you have to do type conversions. It gets really hairy.
Right.
I don't know the reason why they set up that way.
Right.
But it drives me nutty.
Yeah, which brings up a point
Yeah.
that if you don't know the exact type that you want to get to, you could have different code based on that specific type. The goal of generics, kind of bringing it full circle, is to make it so the types don't matter. That's all we're trying to get to. We're trying to get to a point where we can write the same code and reuse it for strings, for ints, for floats, for doubles, all those kind of things. So that's where we're headed. We need types because at compilation, the code, because it's strongly typed, needs to know what kind of type it's expecting right here. If it finds something it's not expecting, it's going to say, hey, hold on. It's going to give you the red errors, the flags, suggestions for updates, those kind of things. Also at runtime, if you're using a type that maybe doesn't, and we'll get to this as we go on, if perhaps it doesn't conform to the equitable protocol, then we're going to get a crash at runtime. Okay? So there's possibilities of those things. So like we mentioned before, like Aaron was saying on line 13, Swift is strongly typed. We want to keep it as strongly typed as possible. But leveraging the power of generics, we're able to use many different types and code one time. So let's get into it. Any questions before we go on? Any questions about what we just said? Okay. So line 17, start with generics. So on 19, we just have a function right there. Can anyone say what they think that function does? Swap two ints.
Swapping two integers.
Pretty much, right? So that thing is waiting for ints to come in. How do we know that it takes ints?
Because you're designating it in the initializer.
Right, right. We're explicitly saying int, right? We see it right here and right here. So this function will only take ints. We can call it with some int for 3, another int for 107, and then we call the method. Does anyone have questions about why we have these ampersands here? Is that clear or questionable to anyone? Questions?
In and out.
Yeah. So in and out, I'll just talk about it just for a bit. In and out allows us to manipulate arguments that are passed in. So we're able to change those And that's why we put those in. That's why we leverage this ability to in-out these specific arguments. So we call the function, it works. Since this is like 300 lines long, I'm probably not going to be executing this playground. I'm just going to be reading it down. So we can print it out. On line 32, we could see swap2ints only works with ints. What if we want it to work with strings?
You have to switch out the int definition to a string.
Right. So on line 35, that's exactly what we've done. On 19, we have swap2ints, and it takes 2 integers. On line 35, we have swap2strings, and it takes 2 strings. Easy peasy, right? But let's say that we have to update maybe swap2ints, and maybe we want to swap it a different way, or we want to do something differently. If we change that behavior from 20 to 22, we'd probably have to change it in every single other version of this method that we have. We'd have to change it for the one that swaps ints, we'd have to change it for the ones that swaps strings, and on and on and on. So we're trying to save ourselves some time. There's a famous acronym called DRY. Does anyone know what DRY stands for in programming?
Don't repeat yourself.
Exactly, Felix. So do you want to talk about that for a bit and share it with some people, like what it means, or?
No.
Okay. I'm going to elaborate on it a bit.
It's my favorite thing is copy and paste.
So the idea is don't repeat yourself. Let's say you have some code, like, for example, swap2ints and swap2strings. The method bodies in both of these methods is exactly the same. So you're repeating yourself. There could be a chance that you mistype it or something like that. Maybe you change behavior on one method and you don't change it on the other, and you expect some kind of output, you don't get it. So that's why we want to prevent how much we repeat ourselves inside of our code. And as we go through generics in the conversation, we'll figure out and view how we get to do that. So I'm going to continue going on unless anyone has any questions.
Well, the alternative is copy pasta.
Yeah,
Yeah.
we want to prevent that.
Just copy and paste and make one change.
So we did it with ints, we did it with strings, we're moving down. Again, this is all from that Apple documentation. So we did it with 2 strings, it works the same way. How about let's do it with doubles? We see the exact same code. We've just changed the explicit type on line 51 from string to double. Now the same function does a swapping with doubles. Great. What we want to do next, here we go. This is what we talked about right here. Notice that the body of each function is exactly the same. What does dry mean? It means don't repeat yourself. Are we being dry here? No, we're replicating that same method body through these 3 functions. So how can we make the swap function work with any kind of type? We change it out to use generics. So let's pause here real quick and just look from 70 to 74. Are there any, is there anything weird looking about this? Or does, with a raise of hands at the beginning of this, we established that some people haven't used it and some people have used generics. So for the people who have used generics, what specifically can you point out that is the generic in here?
The T in the angle brackets allows you to defer specifying what type is being used until you actually call the function.
Right. Does anyone have any questions about that?
So you have to specify what you want when you call it, though?
Or the compiler can infer it.
Or it can infer it? Okay.
So the T acts literally like a variable.
It's
that can hold like
It's almost like a macro,
any
yeah.
type.
It's a placeholder.
It's a
It's a placeholder, yeah.
Yeah.
That's
And
so nice.
yeah, and I'll get to it as we go further down, but the best practices are to use T, U, or V. Just a heads up. So what Felix was saying is on line 70, we have the T in the angle brackets, and we just specify what type we'll be passing into it. So this is a placeholder right now for the type that we will be passing in. And you also notice that we have T's for these explicit types in the arguments right here and right here. So let's try out our generic function with different kinds of types. We're going to run it with int, string, and double. So we have the function definition here. Now we're going to actually implement it further down on these lines. So here we go with integers, swap 2 values. We're leveraging this function right here. And the T goes away. Is anyone questionable about why the T goes away or anything?
Why does it go away?
Why does it go away? Okay, so let me think about how to phrase this. The T goes away because on line 80, swap 2 values knows from the 2 arguments that it's accepting
Oh,
what kind of types.
Yeah, you're telling the compiler's inferring.
Yes, it's
Yeah.
inferring.
Okay,
yeah.
there we go. That's what you were saying.
And the only limitation here is that because you only have T instead of T or U or V, both of the values that you pass in have to have the same type.
Okay.
So you can't pass like a string and an integer if you're just using T.
Yeah.
You'd have to use T and U or something else to specify a second type.
Okay, so there are still some limits.
One placeholder.
It's just one place.
One placeholder per type.
Yeah.
Pretty much. What kind of ones would you want to be expecting?
Mm-hmm.
Okay.
Okay, so we see it for ints. Scroll down. That's it for strings. You see how they're the same method signature, but we're just passing in different types. I think that's the point to really underline tonight. Works with ints, works with strings, works with doubles. Fantastic. Any questions?
So if you put T and U, like on the second one, I mean, just for the sake of argument, in the angle brackets, what would that look like?
A T and a U?
Okay, got it.
Oh, I'm sorry. I was
No, I
asking
mean,
for
it would just,
clarification.
what would it say, like, and then angle bracket?
Like if
Inside of here.
T,
Oh, we
comma,
put
U?
T, comma,
T,
U.
comma U.
Is that the proper syntax if you were getting two
That's all I'm
placeholders?
asking.
Okay.
Would it be a T and comma U?
I believe so, yeah.
Okay.
And we'll get to it further down as we
Yeah.
pass in more
Okay.
as well.
Is this only for Swift 4.0 or is Swift 3.0?
I believe this is for Swift 3.
3, 2.
Oh, great. Okay. Okay.
Okay, so we've...
I did it. I can't remember. What?
Was there a question here? Or?
Yep, it's comma. T,
It's
comma,
comma.
U.
Okay.
Yeah. Okay.
So David,
Yeah.
So we're trying to be dry.
Mm-hmm.
So do you then just have signatures for the int strings and doubles? So you're not repeating all your code, or like what makes this?
What makes this dry?
Yeah, because we're still using.
I guess maybe let me contrast the function on line 70 with one that takes an explicit type further up. So let's say this one, the doubles. I'll move the... So the doubles right now explicitly takes two doubles, right? And if we go further up, we also have variations of this swap 2 to take care of doubles.
It's taking it from the var. Okay, I got it.
Oh, you got it?
Yeah.
Okay, okay.
I thought it was taking a signature.
Okay, so we've covered it for int strings and doubles. We've also mentioned the fact that we can pass in multiple types and then, refer to them in the arguments as well. So we're going to scroll further down. T is our way of putting a placeholder for type. It goes between the angle brackets right after the method name. Moving on to type parameters, this is kind of reiterating what we just said. The type parameter is replaced with an actual type whenever the function is called. Does anyone have any questions about how that happens, how it gets replaced? Okay, I'm going to keep going. Next, naming type parameters. In most cases, type parameters have descriptive names such as key and value in dictionary. Like dictionary has a key and a value. An element in array, so an array has types of elements, which tells the reader about the relationship between the type parameter and the generic type or function it's used in. However, when there isn't a meaningful relationship between, it's traditional to name them using single letters such as T, U, and V. That's what we mentioned before. Always give type parameter upper camel case names such as T or capital M, my type parameter, to indicate that they are a placeholder for a type, not a value. Any questions on that? Okay. Generic types. Custom classes, structures, and enumerations that can work with any type in a similar way to array and dictionary. Let's build a stack. So we're building a structure right here. And we're leveraging the fact that we have an explicit type in here. So we're going to create an int stack that deals with integers. So on line 114, we initialize a variable with an array of ints. On 116, we create a mutating function that allows us to push items of type int onto that array. We also on 120 have a function that allows us to pop. Pretty straightforward, but explicitly typed with ints. Here, here, and here. On 125 through 127, we actually leverage the code that we've written right here. Now, let's change up this int stack into a generic stack that allows any kind of type. Here's what we do. So I want to try to get these both on the same.
Yep, error.
I'm gonna just leave it for now. Yeah, we've got lots of stuff. Yeah, I'm like that too. I just see the red. I'm like, I gotta fix that now. So we've got the int stack and we've got the generic stack. So how about let's just talk about this one. I'm having a difficult time getting them on the same screen, so we'll just focus on 131. What we've done is we've taken the int stack and we have pulled out the int. I mean, we just renamed it, right? So it used to be named struct int stack. Now it's struct stack with the angle bracket saying that this is an element coming in. We maybe have seen element further up before when we talked about arrays. Does anyone have any questions about like what happened to the T and the U? Why are we using element here? Does it?
Arrays.
Exactly. So did everyone hear Merritt? Arrays use elements. Yeah. So that's going to be an element right there. On 133, we're specifying that, you know, before we had it in the int stack, it takes an array, or it creates an array of ints. This one is creating an array of elements. When we actually call this function, we're able to specify exactly what type that element will be, and then we can use it in the same way to push and pop elements.
I think it's less important that arrays use elements, but your stack uses elements.
Right.
Right?
Yeah. Do you want to elaborate on that a bit, Felix? Or?
Well, you can implement your stack in a lot of different ways. But what the stack is the larger concept, not the fact that you implemented it using an array.
I guess.
So, and I'm sorry, aren't arrays, like the actual array is a stack, right? Internally within the Swift library, it's implemented as a stack, right? Is that where you're coming from?
No, I mean, if you're writing this class or this struct for other people, for yourself or other people to use, or you're using it for yourself and you're coming back 6 months later, you don't really need to know the fact that it's implemented with an array, right? You're going to write up your documentation based on the fact that this is a stack, that you put stuff on the top and you take stuff off the top. And that's the important part, as opposed to how you implemented it with an array.
Right. Okay, so we just covered the struct. We're using a generic type, and we're specifying it at the top of the struct. And as it flows through, when we call it on lines 144, 149, and 154, we're utilizing the stack that we've created to use generics, like the elements that we're going to be holding inside of that stack, to use an integer, a string, or this should be double. Do a quick update of this. Jeez. I'll just leave it for now.
So in that case, you have to tell it what type.
The explicit type, yeah. Any questions, Aaron?
It doesn't like the double 1.1.
Yeah, I've got a.
Oh, because you put stack in, that's why.
Yeah.
I mean, I haven't actually used it, but isn't there like a awesome array of anything? I can't remember. It's called any.
Oh yeah, okay.
Yeah, it's like you can put anything in there,
It'd
right?
be very loose though.
I love that. I mean, that's like Objective-C array.
Well, I mean, that's a great time to maybe talk about that specific use case.
Yeah,
like, if
sorry,
you
I
allow
don't
for...
want to derail off.
Oh, I'm happy
But
to. We can come back to this later, but I think it's important that you bring up a point about what if you had an array, like Tyler, you mentioned earlier, that you want to keep an array with, like we mentioned earlier, holding an array of ints, right? These are all the same type. So if you iterate through the array of ints, and maybe you want to do some swaps, or you want to do like maybe each element plus one, you'd want to have every single element in the array being of a type int, because then you can do a plus. However, if you have it loose, super loose, as loose as possible with an any type, then you can't really do, you can't guarantee that there won't really be collisions or complications along the way.
And you end up having to look at every item and figure out what type it is to see if you can do the operation or not.
Exactly.
Right.
Yeah.
Or assume.
Well, that's what runtime errors are for.
Yeah.
Okay, so we're moving on. Anyone have any questions about this right here? Okay, so we'll move on.
Awesome.
Okay, I'm just going to check the time real quick. So we're about halfway through, and we're on line 159. So extending a generic type. When you extend a generic type, you do not provide a type parameter list as part of the extension's definition. Instead, the type parameter list from the original type definition is available within the body of the extension. and the original type parameter names are used to refer to the types parameters from the original definition. So we'll look at 163. We see that we're creating an extension for stack, and we're leveraging the fact that when we defined or declared stack, we use the word element. Does that make sense? Is that pretty clear? Okay. Okay, I'm going to keep going. 171. Now this top item can be used on any kind of type in stack. Let's see. If okay, this is related to this. Top item in stack. Okay. Does anyone have any questions about that, or would it walking through it be helpful?
Could you just go back to the stack on 131 for a second?
131? Sure.
Go back. Also, it has to use the same name.
Yes. Mm-hmm. Yeah. Okay. Any other questions on this one? Okay. I'm very happy to just dwell on one thing if it's helpful. Okay, moving on. Type constraints allows you to be a bit more strict as to what kinds of types are allowed. So let's say you're being really generic. You can kind of say, you know what, hold on, not everything. We're not going to allow any type here. It has to be maybe this specific type. So one is hashable. So a type must provide a way to make itself uniquely representable so it can be used to query for the value for the hashable key. Does that make sense, or does anyone have any questions, or want to dwell on that for a bit?
Can you explain again hashable?
Sure. My understanding of hashable is that, let's say you have a dictionary, and a dictionary is made of keys and values, right? Let's say, what if you had two of the same keys? How would you get the value that you want? You wouldn't be able to, right?
That's why every key has
Yeah,
key.
exactly. So by being hashable, that means that it's specifically unique.
And hash is a data structure, right? A hash.
I can't comment with 100% certainty.
Where the name comes from.
Yeah, I'm not sure. I can't really comment on that one.
A hash is where you apply some mathematical function to look at the data that you've got and figure out a unique identifier for it.
Mm-hmm.
So it's a way of turning what you have into a unique. Typically, it's like an integer ID or something.
Right. Okay. Forget about equitable right now. We'll get back to it as we go further down. So moving on, 187, type constraint syntax. So this is how we leverage these type constraints. So we have some function, and we say that it's going to have a generic t, generic u, and then we utilize the t and the u within the arguments, and then do the functionality in the middle. So the difference is right here is we're saying that t has to be a subclass of some class. U has to conform to the some protocol, whatever this protocol could be. So this allows us to specify and kind of limit what types are allowable here while still being generic and very loose. This allows us a bit more, to be a bit more specific about what types we'll allow in here. Any questions on that one? Okay, I'm gonna keep going.
Is there an example on the use case?
Let's see. For this right here.
For some function, yeah.
Let's see, let's talk about it. So let's say that we have, okay, I'm going to jump forward a bit to explain this one a bit more. So we have a protocol equitable. So equitable means that, let's say we have two integers. Int conforms to the equitable protocol in the fact that it satisfies three conditions. We can use a double equals on two of these like ints to check equality if they're equal. We can also use a bang equals to check that they're not equal. And then there's a third one, it's further down, but there's three that equitable types that conform to the equitable protocol must satisfy.
Triple equal?
I don't know. I'm not sure about that.
Okay.
But so it's just, I mean, let's say you create some kind of data structure that's like an address, maybe like one address versus another address. Can you compare those two? I guess you could, right? Plus equals like a string or something like that, but then it turns into a string. I hope that maybe we'll get further down to it, but
Oh, yeah, I can wait.
okay. You know, if we don't get there, please bring it up again.
Okay, thanks.
Right. Okay, so on 195 now, type constraints in action. So maybe this will explain it a bit more. So we have a function called find index of string. We pass it a value to find a string and an array of strings, and we're returning a optional int here. So what it's trying to do is it's trying to go through with every single string inside of the array and find out if the value that it's currently iterating on is equal to the value to find what we're trying to find. So does the functionality of the method on 197 to 205 make sense? Okay. So we have type constraints in action. We're saying that that's just a regular method, right? It's very strictly typed. So here's the usage right here. We're able to create a string or an array of strings, and then we can leverage the method find index of string to look for that specific string llama inside of the array of strings. If it's found, we're going to print it out. If it's not found, we're going to just not do anything because it's optional unwrapping. Moving down, so now we're going to take it from this explicitly typed function on 197 to a generically typed function on 217. So let's update this to be as generic as possible so we can find the index with types in addition to strings such as int and double. So what we've done between these two methods is we've got our favorite angle brackets with the t in the middle of it. It's pretty much, we know we're dealing with generics here. Next, we're moving on into the arguments of the method. We see the two t's. Makes pretty much sense, right? It's kind of some pattern matching that we can see in here, right? Then we go into the method body, 219. We just enumerate the values. We get an index and a value, and then we just run through. You'll see on 120, the Swift compiler does not like this line. And I'd like to talk about why at this. Does anyone have any ideas? And if you know, I'm very happy for you to just say it too.
It has to do with that what we were talking about earlier with the equatable protocol.
Yeah, exactly. Yeah.
It doesn't take a protocol, that function.
No, there's no protocol specified at all. It's loose. It's a loose generic, right?
Okay.
Yeah, we see that on 217. Next to those t's, there's no type specified at all, or protocol or anything, right? It's just a t. So it doesn't know. It could be passed in. I wish I had an example of something that's not equitable that I could share, but I'm at a loss for it right now. If anyone knows, please say it. Aaron, do you have a question?
Oh no, I mean I just.
How do you fix that?
Yeah, that's what I was going to
How would
ask.
you fix it?
Yeah.
Okay, we're going to move down and we're going to take care of
Yeah.
it. So we're dealing with that line 220. Why doesn't it like it? Gotcha. Not every type in Swift can be compared with the equal to operator, equals equals. If you create your own class or structure to represent a complex data model, for example, then the meaning of equal to for that class or structure isn't something that Swift can guess for you. And that's that type inference and all that kind of stuff where it comes into play, right? Because of this, it isn't possible to guarantee that this code will work for every possible type T. And an appropriate error is reported when you try to compile this code. So it's going to crap out in compile time. How do we fix this? The Swift standard library defines a protocol called equitable, which requires any conforming type to implement the equal to operator. Well, Neil, that's the one. And the not equal operator, bang equals, to compare any two values of that type. I guess it's just the two. To compare any two values of that type. All of Swift's standard types automatically support the equitable protocol. So let's update the find index function to force generic types to conform to equitable protocol. So let's just compare. We've got 0 kind of protocols being explicitly specified here, right? We move down, and we've got them right here. So we're saying T must conform to the protocol equitable. And we just have to say it one time, yeah? Because these T's take care of it right here. Any questions about this one?
So that'll compile. Okay.
Yeah.
Maybe you got to do.
You got me, Elliot.
Wait, is that copy pasta?
It is.
Yeah.
It is, Felix. That's why we want to be dry.
So it seems like in every case where, we're going from being totally unrestricted and now we're restricting and restricting and restricting.
Mm-hmm.
Just so that we can get
just for the equals, just to check equitability.
Oh, because some types you can't use equals.
Right.
Yeah.
Right.
What would an example of a type you can't
I can't really think of an example. I wish I could.
Well, anything that's not, I mean, any custom type, right?
Yeah,
Yeah.
exactly. Yeah.
You have to be able to tell it, which would go into a whole nother thing, right? How you make a equitable protocol for your object or your class.
Right, right. Does that answer your question, Elliot, or is it still kind of unclear? Maybe let's pause and talk about that for a bit. So let's say we create our own data type, and we're comparing. Let's call it dog. I don't know. Okay. Adam likes using the word dog to. So let's say we create a dog class. How do you, like, literally we're creating a dog class. We have an instance of a dog. We have another instance of a dog. How do we compare those two? Like, how do we say this dog is equal to this dog? Is there any way to do that? We'd have to specify it, right? We'd have to write code that would do the comparison.
Has a tail, has 4 legs.
Exactly,
whatever.
yeah.
might have the same name, but might have like different characteristics or.
Yeah, yeah. We need to explicitly state how we are defining comparison.
Yeah.
What is a true this equals this, that kind of stuff.
Said like all the Swift standard types automatically support equatable. Just when you start creating your own types.
Yes.
Right.
That's when you have to implement. Say
Yeah,
just
because you got a generic
protocol.
type, but
Yeah.
so you have to.
Yeah.
So you have to specify equipment.
A way to think about it is, you know, when, like she was saying, when you write out data, like if you write out your own data structure, you got to conform to some kind of, I can't remember what it's called, but you have to describe exactly how the data is written out and written back in. Because if you don't use the standard types, it doesn't know.
Right.
So
Could be
I mean, it's
sizes,
similar. It's
yeah.
a similar concept.
Basically, those operators are actually functions. It's function with sim.
Exactly,
With
yeah.
simple,
Yeah.
So you have to implement how that data is going to use that specific function.
Exactly.
Yeah.
Compare apples to apples, I guess.
Yep.
Yeah.
Okay. Any other questions before we move on? We're making pretty good time on this one. I think we might be able to finish it. So we've got about 15 minutes left. So I'm going to continue going. 243, the above addition means any type T that conforms to the equitable protocol. Now the function can be called with any type that is equitable, such as double or string. So we can actually leverage it now. And we can use it on doubles, we can use it on strings, pretty straightforward. Moving on, 251, associated types. When defining a protocol, it is sometimes useful to declare one or more associated types as part of the protocol's definition. An associated type gives a placeholder name to a type that is used as part of the protocol. The actual type to use for that associated type isn't specified until the protocol is adopted. Associated types are specified with the associated type keyword. There we go. Associated types in action. We're just creating a protocol called container right now. Associated type item. This alias provides a way to refer to the type of the items in a container and to define a type for use with the append method and subscript to ensure that the expected behavior of any container is enforced. So we specified inside of the protocol, we say that we're going to be dealing with item. On 261, we have an append. It must be possible to add a new item. So we specify the type right here. 263 must be possible to count the items in the container. 265 must be possible to retrieve each item with the subscript that takes an int index value. Any questions on this one? Okay, I'm going to keep going. 268. Note, we have not defined what types the container can hold. Any type that conforms to the container protocol must be able to specify the type of value it stores. Specifically, it must ensure that only items of the right type are added to the container, and it must be clear about the type of the items returned by its subscript. Here's the non-generic int stack from before as it conforms to the container protocol. So you remember that I think on 131 we specified our int stack, and it takes int. This one is conforming to the container protocol that we specified right up here. Yeah? So we just have the colon container. And now, by conforming to the protocol container, I'm going to do a really quick pop quiz. What methods are required for a container type? Anyone?
Append and subscript. Right?
Yep, and one more.
Count.
Oh yeah, count.
Okay. So all we're doing right now with our int stack is right below our two mutating functions, we're conforming to the container protocol. We have our append, count, and subscript. Yeah. So conformance to the container protocol defines what kind of items we will be dealing with explicitly. It turns the abstract type of item into a concrete type of int for this implementation of the container protocol. It's actually not necessary because int stack only deals with ints. Remember that this is not the generic function, this is the int function. If there are any questions about this stuff, you can refer to that link, the Apple documentation.
Why is there an error on the word return item without the flag?
Let's see what the suggestion is. Missing argument for parameter 1 in call. I'm not sure right now, but I'm going to continue going. We can loop back to this later on. Now let's make the generic stack conform to the container protocol. So we had our int stack. Now we're dealing with a generic stack right here. So you'll see that we are still conforming to the container protocol, and we're bringing in those three functions at the bottom here, yeah? No need to type alias here because Swift infers that element is the appropriate type to use as the item for this particular container. Conformance to the container protocol exists right down here. Next, extending an existing type to specify an associated type. Extend an existing type to add conformance to a protocol. Swift's array type already provides append, count, and subscript with int index to retrieve its elements. So you can do it like this. Extension, array, leverages the protocol container. Using type annotations to constrain an associated type. Add a type annotation to an associated type in a protocol to require that conforming types satisfy the constraints described by the type annotation. Here's an updated container that requires the items in the container to be equitable. So here's our protocol container. You see right here? This is what we're talking about right here. Type annotation to constrain an associated type. Now the container's type has to conform to the equitable protocol. Any questions on this one? Okay. Generic where clauses. This is where it gets really interesting, I think. A generic where clause starts with the where keyword followed by constraints for associated types or equality relationships between types and associated types. You write a generic where clause right before the opening curly brace of the type or function's body. So this right here is our generic where clause. So does anyone have any guesses on what this specifies?
It allows you to specify different types for C1 and C2 as long as their type alias items are the same.
Yes. Does everyone get that, or does anyone want to pause on that and discuss it for a bit? Okay, I'm going to keep going. Now let's test it out. So we test it out. We leverage it. Extensions with a generic where clause. You can also use a generic where clause as part of an extension. The example below extends the generic stack structure from the previous examples to add an isTop method. So we have an extension on stack where the elements it deals with are equitable. We create a new function to leverage onStack named isTop, and it takes an item of a type element and returns a bool. So it uses that equitable, so you have to make sure the types being passed in can be compared with that, equal sign. There we're using it right there. Notice if you try to call isTop on a stack whose elements aren't equitable, you'll get a compile time error. So this is just an example of doing that. You can use generic where clause with extensions to a protocol. Here's our generic where clause, the extension to a protocol. Let's prove that it can be used with any type that conforms to the container protocol as long as the container items are equitable. So here we're leveraging it. 999, these are all equitable, starts with 42, and this runs. You can also write a generic where clause that requires item to be a specific type. So we have it defined right here as our explicit type that we want to deal with as a double. Here we go. And we're using doubles. You can include multiple where clauses. Just make sure you separate them with a comma. We're getting pretty close to the end, I think. I just want to check on the time. Okay, we've got about 6 minutes. Associated types with a generic where clause. You can include a generic where clause on an associated type. Suppose you wanted to make a version of container that includes an iterator, like what the sequence protocol uses in the standard library. Here's how. So we have a protocol container, have an associated type, and we have the associated type iterator conforms to iterator protocol where the iterator element is equal to item. Any questions on this one? Okay, keep going. 480. For a protocol that inherits from another protocol, you add a constraint to an inherited associated type by including the generic where clause in the protocol declaration. I'm going to read that one more time. For a protocol that inherits from another protocol, you add a constraint to an inherited associated type by including the generic where clause in the protocol declaration. For example, the following code declares a comparable container protocol, which requires item to conform to comparable. So here it is right here. Where item conforms to comparable. And I think this is right around the end of the talk right here. Generic subscripts. Subscripts can be generic, and they can include generic where clauses. You write the placeholder type name inside angle brackets after subscript, and you write a generic where clause right before the opening curly brace of the subscript's body. Does anyone have questions about this one? I believe this is the end of the talk. So, is there anything you want to loop back to and talk about? We really don't have that much time.
I can't.
Well, I'll be posting this up tonight so you can parse through it. If you have any questions next week, bring them next week. Also, if you have any questions about this, post it up on the Meetup. We've recorded this, so this will be online if you want to review this stuff. I realize this is a lot to take on. This really reminds me of when we discussed closures as well. So this is probably something we'll be looping back to over and over and over in the future. All right, so thanks for being here. Thanks for your time and your attention. Appreciate it. Thanks.
Awesome.